Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Welcome to Chai with great open source creators, great researchers. In this episode, I interview William Falcon, creator of PyTorch Lightning and CEO at Grid.ai. We talk about William's journey from Navy SEAL trainee to an iOS developer in the financial world to becoming a founder of a company and then later transitioning into deep learning research. We learn about how William has applied his passion in different fields, how that has helped him, and how the inception of PyTorch Lightning has happened, the core philosophies behind it, and the community, how that has come together throughout these months. We touch upon a lot of things and briefly upon Grid.ai and its mission. All of these things that we talk about are there in the show notes, so please feel free to check them out. But without further ado, here's my interview with the creator of PyTorch Lightning, William Falcon. Please enjoy the show. I am very excited and honored to be talking to William Falcon on the show. William, thank you so much for joining me on the podcast.
Yeah, thank you for having me, Sanyam.
So you've had a very interesting background. I usually start by talking about my hero's background. You were training, you were going through the Navy Buds training. I'm from India, so please help me understand what that is. And I read that you transitioned into the intelligence unit from there. What was that about?
Yeah, so BUDS stands for Basic Underwater Demolition Skill Training. So it's if you want to do special operations in the Navy and you want to go into the SEAL teams, BUDS is kind of the first training thing that you do, right? So and then from there you go to advanced SEAL training, and then more training once you get to a SEAL team. So it's I think if you Google Navy SEAL stuff, like BUDS is I think what comes up the most.
It looks very scary for sure.
Yeah, it's I think like a lot of people can do it. Like it's really, I know it's silly to say, but it's mostly mental. It's just about not quitting, right? Like I think the hardest times in BUDS for people generally are like waking up, right? Because you're like, wow, I have to do this again all day. Like that's crazy, right? So yeah, so I got started. So I started my career in the U.S. Navy, right? So I was undergoing BUDS training, and I was there for a while, for a few years. And the first time I went through training, I got pneumonia, so I had to like kind of start over. And then the second time, I came out of Hell Week with some injuries, and that was a problem because at the time the military was kind of downsizing. And so if you had any issues, which I already had pneumonia once, so they were like, no, we're not gonna do this again. They kind of like were trying to figure out how to downsize. And so if you came out of that, they basically gave you options, right? They're like, you can do something else in the military or leave. And so I actually ended up going to one of the SEAL teams. It's called SRT-1 now. And it's they do a lot of really cool intelligence stuff, right? And so I was working with them for a bit, and then I think like I was not able to go back to training, so that really sucked to finish SEAL training. So then I left the Navy, and I was trying to figure out what to do next, right? So I think my whole life I was like, okay, I'm gonna do this for 20 years. So there was no backup plan. So I was like, all right, well, I don't really know what to do now. I think the only skill set I really had, I learned a lot of stuff in SEAL training. But I think the tangible, translatable skill set was finance. I just been trading stocks since I was very young. So I ended up walking into Merrill Lynch and got a job. And that was very shocking to me because I was like, well, that's crazy. And so I did that for a few years, and then during that time, I think it was like there was like a Stanford class for online about iOS development, and I was like, oh, this iPhone stuff looks cool, and like it was like 2010, like it was like 2012, I want to say. So like iPhones had just started to be a thing, and I was like,
Mhm.
yeah, maybe I'll make some apps, and I knew nothing about CS, right? So I just started coding Objective C and Java, which were like the worst languages to start. um,
Till
and
date they
then
are.
yeah, and it was so difficult. I remember like doing Objective C, and like that was right before Arc came out, which is the automatic reference counting. And I was going through the code, and like literally the first code I've ever seen. And like I noticed there was a pattern. You had to like call a line in every function and then call another line at the end. And it was like malloc and free, right? And then I was just like, I don't know why, but like when I don't do this, things crash, right? So I was like, I guess I'm gonna do this. And so then R came out, and I was like, oh, that's what it does. That makes sense. So I continued on the iPhone track for a while, and I was still working in finance, but I started getting into like, how do I automate a lot of these things, right? Obviously, hedge funds do a lot of this, but I was like more excited about the automation and like doing this like quantitatively, but I never studied math or anything. So I ended up running into friends, and I got encouraged to apply to kind of go back to college, right? So I ended up applying to Columbia University, and like my grades in high school were terrible, right? So like I was like never gonna go to an Ivy League. So I was like, yeah, I was like, this is not gonna happen. But I studied hard, and I think like a lot of what I learned in SEAL training was about not giving up. Like I think that sounds silly, but like really just like it's not about what you can do, it's about how much energy and effort you can put into it. And so I was like, I don't know, I just got through this. Like, I'm pretty sure I can study for this SAT thing and like figure it out, right? So I ended up doing fairly well, and then got accepted to Columbia. And then, like night and day, just like jumped straight into CS. I already knew a lot of programming then. So I was like, I think I was ahead of my peers. But then I started getting to math, right? And I was like, okay, calc. And yeah, I did not do well in calc in the first like half of my calculus class. So I ended up studying really hard, and ended up doing really well in that class, and actually loved calculus after that, and ended up majoring in math as well. And I think I was like, yeah, it was I was like everyone who showed up to Columbia at that point, they all knew like calc 1, 2, 3, 4, linear algebra from high school, right? Like they were super prepared. So there, I was playing catch up for a few years there, just to like learn all the math. So it's never too late. If you want to go back to school, just do it. I promise it's fine. Like pretty much after like year two, everyone's on the same footing. I continued doing mobile apps, and during that process, I ended up getting recruited by Goldman Sachs to basically build some. They were like there's this group called Marquee. You guys should check it out if you want to go into finance. But they're working on a lot of new stuff like internal apps, right? So they a lot of those things like they'll spin out into startups on their own. Um, and back then, they were like, it's a startup, and I was like, okay, great. And like, yes, it was more free, and like you had less red tape, but you had a lot of money, and you had recruiters. So like now that I know what a startup is, that's definitely not a startup, but it's close, right?
Okay.
um, and so yeah, I ended up doing that, and then left finance after like a year because I really got into deep learning,
Mhm.
and I wanted to use deep learning on the trading floor. And like the quote that they said was, you can recommend movies and people won't like them, that's fine, but if you recommend a $2 billion trade and they don't like the trade, like that's a problem, right?
Yes.
So I think that still holds true in finance today. I'm sure hedge funds are more open to it. So I left, and I started my own company, right? And that was to help people like me, low income students who came from different countries. If you're not from the US, and I assume like the US educational system is a mystery, right? I mean, it was to me. I'm not from here either. I'm from
Mhm.
Latin America. So, for people like us, when we go to the United States, like you don't know all the things that these people know, like SATs, how to apply, scholarships, like what colleges to go to, so many details. So the startup we used, I think it was like probably some of the first NLP to go into production, where we basically built a system that would go through chats and like help you. They would like talk to you, but like there were human in the loops, obviously, to help you like figure out how to apply for financial aid and like what colleges to go to. So we ended up growing that company to about 65,000 users, and they got about I don't know, $38 million worth of financial aid, which was really cool. And then, I continued doing deep learning. And so I then, I applied to PhDs during that time frame. And I ended up getting an offer to work, to go to NYU and work with Kyung-Hyun Cho and then later Yan LeCun, right? And so I was like, yeah, of course, this is amazing. And at the same time, we had an amazing offer to acquire the startup. So we sold the company, and then I joined NYU and started the PhD. And then that's probably when I started working on Lightning, probably a few months after that. So I was coming from the startup world where I had spent 2 years putting models into production, and I used a lot of TensorFlow for the first year and change, and then
Why
switched
would
to
you do
Python.
that to yourself?
Yeah, well, because back then, I was like, oh no, TensorFlow's faster for inference and all this other stuff. And I was like, okay. And then the papers that came out were in TensorFlow. And so it was just easier to just adopt the papers and then modify for whatever. So I ended up rewriting a lot of the stuff into PyTorch. And then we ended up using PyTorch internally for production. And it was great. And it worked super well. And we were streaming real-time chats, right? Like you text us and then we give you a reply very quickly. So it was great.
So
So I was like, okay.
you were analyzing text in real time, and this was a little ago before PyTorch had shifted their focus on being more production ready, right?
Yeah, before that, exactly. So we were still running even stuff on the Python runtime. Like we were just scaling horizontally, right? Which was great. And what we would do is we had many models. Like we had a reinforcement learning model that would basically, given what you talked to us about, we would help guide you into a decision about something that was beneficial for you, right? The reward function was your financial health, like how much money you got for college, and then the actions were what you said to us and what we said back to you, and then we ended up kind of walking you through that process, right? And then other models that were around taking all the chats and everything you did and putting them into context, right? So you chatted, and maybe we were talking for a month, and I have to be able to understand that and then suggest things to say to you to continue you in that journey, right? So that's a lot of what we built. And this is before BERT and all these other things, right? So it was still pretty good. I think even today probably still works well. BERT would definitely crush it if we used it now. But it was, I remember giving a talk that year, and I don't think really, it was in New York, and there was all these companies, and people were deep learning production, how, right? And I was like, it's not that crazy. So I think we were definitely one of the first people to start pushing that and real-time chats. And then I started my PhD, and Kyung-Hyun is a phenomenal NLP, right? So Kyung-Hyun was one of the people who introduced attention to the world, right? GRUs, really incredible stuff, seek-to-seek models. And so I wanted to understand that stuff really well. So I spent the first few months doing NLP research. And then BERT came out, right? And by that point, I'd already switched to speech or something. So I was like, okay, great. NLP is very consuming. You have to do a lot, you BPE and lowercase and all these different things, right? So the
Mhm.
processing is very crazy. And so the first Lightning really was built for NLP, right? It was built to do seek to seek, to do transformers, to do all that stuff, because that's what we were doing for research. And then from there, I shifted into audio, right? So I started working on tachotron and kind of speech syntheses. And so it continued with that recurrent idea and then sequential models, right? And so that's why if you use Lightning today, you see they're just built in everywhere. It's this ability to go through hidden states very quickly and reference things and do attention, because it was built around that first. And then, I continued that research for probably 6-7-ish months, and ended up getting into a bottleneck where PyTorch didn't support complex numbers. And so I couldn't do my research. And so the decision was learn Cuda or go to TensorFlow or switch directions. So I switched directions.
Makes sense to me.
um, I did give it a fair shot, though. I did implement this complex number library in PyTorch, and it does work. It's on my GitHub. You can look at it, but it's not optimized for CUDA. So when we were doing these cells, the recurrent was too slow to do anything meaningful, right? So I was like, no way. This is way too much. I wrote a whole complex number library for this project. I'm not going to learn CUDA. This is not the time for that.
Mhm.
um, and so I switched into vision, and I guess my research is more fundamental generally. It's not really about vision or speech or anything. It's about, I guess I always try to come at it from the fundamental. And this is really what Kyung-Hyun and Yan do, right? They focus on core ideas. Wasser Gans, attention, these kind of big things that can like translate to many other modalities. And, what I started to focus on was self-supervised learning. How can we learn without data, right? Without labels. And, we switched pretty hard into that. And that was also when I started at Facebook, right? So I started FAIR as an intern that summer. And, I had open source Lightning before that. It was like probably 2 or 3 months before that. So people at NYU could use it. And then when I joined FAIR, I continued my research into self-supervised learning, but I hadn't gotten to the point. Now, if I knew now what I know about self-supervised learning, I probably wouldn't have done it. But at the time, I didn't know you needed like 1,000 machines to train, right? And so
And
I
William
was
is
like,
not even kidding. It's literally 1,000 machines sometimes.
yeah, it's insane. And so I get to Facebook and I'm like, great, we have a lot of compute. So like, let me use that, right? And at that point, Lightning, I think it only did DP, so data parallel, right? So it only worked on a few GPUs. And so I spent like a month and a half just figuring out how to get Imagenet to run in a few minutes on the Facebook cluster, right, per epoch. So, I ended up adding all the 16-bit precision, all the distributed training, like all those tricks. And then ended up getting, I think when I started at Facebook, like my Imagenet epoch was like probably like 72 hours per epoch, right?
Okay.
But by the time I was done optimizing all of this, I'm like, I worked with, and by the way, I worked with a lot of people at FAIR who helped do this, right? Like from incredible teams. They taught me a lot of what I know today. So a lot of the distributed stuff that you see in Lightning today comes honestly from FAIR. Like it's just like a lot of stuff that we do internally, but it's only a handful of people who do it, right? And so I embedded all this in Lightning. By the time I was done with Imagenet, I was able to train it, get it down to about 45 seconds per epoch, right?
Wow.
Which is insane because to do that, you need about 512 V100s, 32 gigs each, training really fast, also on half precision, right? So that's where the scalability came in. And then I started, but I was doing research. So like in our research world, like we have to search hyperparameters. And so it's not like I was training one model. I would spin up a dozen models, each on 500 GPUs, and like there's still limits at Facebook, so I had to get like permissions and stuff to help out with this. But I was like using a lot of compute, right? And so the cluster manager, who's a good friend now, he would ping me all the time, be like, "Listen, like you're way over your quota. Like I don't know what you're doing, right?" um, and then I think so anyway, so it was really slow to go through my research. So the internship ended and I actually didn't publish anything because we were like we got somewhere, but it wasn't like a state-of-the-art result, right? So I stayed on at FAIR as a researcher, while doing your PhD. And so I continued to like optimize things and continue to work on self-supervised learning. And then, like Lightning had already started to be used by FAIR, and then a few people internally, like not Facebook AI, but like in the app itself and like other parts of it were using it. And so my time shifted from like research to like, okay, can you support this thing? I'm like, okay, sure. Can you support this other thing? Right. I'm like, okay, fine. And so like, I basically spent all that whole fall just like building all these features because people needed them and like trying to do research. And then I was like, okay, I'm like spending all my time coding for you guys instead of doing my own research. Right.
I saw a
So
tweet where you had mentioned that even on Sunday mornings, you're just going through all of the issues. And at that point, you were actually reading every single issue that was being raised in the repo.
yeah, I mean, I still read most issues. Like I've read every single issue, every conversation ever on Lightning, right? Like just because like I think I get very anxious about bugs in my code. Like I'm a perfectionist, I guess. So like I hate having a bug just like sitting there. So I'm just like, oh my God, I have to fix this right now, right? And the for better for worse, PhD is just like hones that ability to just like be obsessive about something. And so I would sit there on the weekends and like, the stuff helps me as well. So I'm like, yeah, of course, I need to fix that too. Like I need it for my own stuff. And then, you had, I think by September, we had like 20,000 downloads, right? A lot of people using this stuff. And by December, I think we had about 65,000 downloads, right? And so suddenly I was like, oh, okay, well, like this is a lot, right? Like
Definitely.
companies were using this, Facebook's using this. So I'm sitting here and like talking to Kyung-Hyun and Yan. I'm like, hey guys, like, I'm sorry, like, I can give you updates in a few weeks, but I'm just like coding Lightning like nonstop. Like that's my update, right? Like that's what I've been doing. And so luckily I had a great set of core contributors and open source. The community was taken off and people were starting to contribute. And Facebook's always been supportive, so they've always been super helpful as well. So we continued, and then like we were just growing super quickly. And then a few months later, I ended up chatting with one of my friends, Lewis, who's currently, he used to, Forbes, the magazine and the website, I guess. He used to head up the machine learning there. And then he went and built the machine learning team at Glossier, which is now a unicorn makeup company in New York, right? And so I was like, hey, listen, like, we want to be able to kind of scale this stuff up, and like companies are asking for a lot of stuff that's just not in Lightning. So why don't we build that out? And like, you come from the big companies, so like let's use your knowledge as well. And so we ended up founding Grid out of that, right? And we ended up raising money and and finally being able to hire people, because even up to that point it was like me primarily coding on
Mhm.
Lightning. I think there's like a shocking stat about open source projects where it's like most open source projects are maintained by like a few hundred people,
Yes.
which is crazy. So please contribute because we need your help, right?
What do you think was the reason for this huge adoption? Because it just started as your own side project. I assume it was out of your own frustrations or just your side scripts that you put together into a repo. What led to this huge adoption?
Yeah, I mean, it's like I come from I've tried every framework for probably multiple years, right? So I used Theano for a year and change to like code stuff up, and then I used TensorFlow for years. I mean, my first paper was on TensorFlow, my second paper was on Keras, right? So I've tried all these frameworks, and then PyTorch just like night and day. And I was just still frustrated because it was like the thing that I needed to do was like when you use PyTorch, you end up writing the same code over and over. Like you have one project and then you get it to work and then you're like, oh, I'm going to add 16-bit precision. And you're like, oh, I'm going to add this distributed thing. And then you go to a different project and then you're like, oh, well, I still want 16-bit and I still want that other stuff. So what you end up doing is you copy that file into a new file and then you change some code, right? And then you
Yes.
end up with like 20 of these files. And then, if a new thing comes out, you now have to add it to 20 other files. So nothing's in sync anymore. And so it just becomes a giant mess. And I was like, listen, this is like very time consuming and super slow. I was like, I need something that will like help me cut through all of this so I can move fast through ideas, right? But because I'm a researcher, I need to be able to have all the flexibility in the world. So like Keras doesn't work, right? Because like it does work for a lot of things, but like if you want to get really crazy, like it has a lot of limitations, right? So then I'm like, okay, well, it's TensorFlow PyTorch, but like I don't want to sit here and do everything manually, right? And so I realized you could automate a lot of the stuff without losing the flexibility, right? And so Lightning came from that experimentation process. And obviously having Facebook use it helped a lot because like they stress tested dramatically, right? Even for production, right? And so we had all these constraints, and by satisfying all the constraints, you end up with Lightning, right? And I'm not sure there are a lot of ways to solve this problem because like what you see in Lightning today now is something where like all of that stuff is removed, all of the boilerplate, but just the key stuff remains. That is what you need to care about for research, right? And then you leave it to us, like research engineers and people who are like focused on making these integrations happen, do that really well. And like when you have Facebook, when you have our team, when you have 300 plus open source contributors, and they're all from top labs pushing the new state of the art ideas, like very quickly, you're going to realize that your own code is going to be very suboptimal most of the time, right? But you can just kind of jump on Lightning and like that code is already super well tested, optimized. It's ready to go for inference. It's ready to go for production. It's ready to go for training. And there are a lot of eyeballs and really smart people looking at it, right? So it's the difference between like building, it's like you buying all the car parts to build a Tesla or just buying a Tesla, right? Like it's going to be super optimized.
Makes sense.
Yeah. So that's what it was. That's how that came about.
And as I was mentioning to you off the record as well, I've gone through all of the examples as my homework, but I really don't use Lightning at work just because the podcast takes most of my time. So, what's the final vision for Lightning? Do you think you've accomplished it, or are you still chasing it? Is it a constant goal, even if you think
Yeah,
you have?
I mean, Lightning is going to continue to evolve, right? I think the API is very stable now. It's unlikely to change, but we will continue to add new things, right? I think like the world of deep learning will continue to change, right? And so I don't know what the next paradigm is going to be, but we're definitely going to be in front of it, right? And I think like when you look at historical like the other frameworks, right? Like phenomenal frameworks, Theano, TensorFlow, PyTorch, um, and Keras, right? Like these frameworks came around when what were we doing back then? We were building models, right? Like we were literally saying layer one, layer two, activation, layer three, activation, layer four. And then that is what Keras is, right? It's a thing to build a network, but it's not to build like a seek to seek. It's not to build like a complicated like models interacting with each other. That doesn't work, right? Because it wasn't designed for that. So and neither do the other frameworks, right? Like PyTorch and TensorFlow, they were also designed for this modular world, and so you end up with a lot of unstructured code. So Lightning, I think where we are today in the world of research, this is the level of abstraction we need to be at, which is models interact with each other in really complex ways. And that's what Lightning is, right? Encapsulates all of that. So you don't have to sift through 20 pages of GitHub code to be like, oh, where's the thing? Like, where's the paper? Like, where is this happening, right? You can read Lightning code and it's very clean. And so to answer your question, like, I don't know what's going to happen in the next few years. Like, I think that this is a good paradigm for now, probably for a few years. But what is that next evolution that's going to happen, right? Whatever that is, like there will be abstractions that come to capture that. But I think we're on top of this stuff all the time, and we move super fast. Like if you submit a bug to Lightning or you have a feature, like we will get it done very quickly. So we will be very on top of new features and new paradigms that come out and just adjust as we continue, right? And so the goal for Lightning is to be the framework for machine learning and deep learning. Like if you want to do anything with deep learning, you should just be using Lightning, because we can abstract all of the stuff you don't care about. And so you can just focus on the work.
The motto on the page is "You do the research, Lightning will do everything else." So it really speaks to that. Um, you come from a very different background. Someone who's in the Navy or in the finance world. Maybe the finance world is somewhat connected to coding. Many people are just afraid to make the jump into the world of coding. What do you think is your reason for success? Because if I were to go to Lightning's GitHub repo and just try to contribute, I would be terrified of even looking at the code and asking, "Hey, is this a stupid question? Can I do this? What language are you guys speaking?" So, do you have
So
any tips for
there,
anyone?
yeah, there's never a stupid question. Like I know you read on Twitter and everywhere else where it's like, don't go to a repo and like fix docs and like do that, right? Like we actually want that. Like come to Lightning, fix docs, right? Like come make a small simple change, fix typos. We don't care. Like get started somewhere, right? Like and get comfortable. Lightning is not scary to code, right? Like I think the code is readable under the hood. I think we just have to understand how it works, right? And I think it's always going to be really hard to make things extremely readable, but we try our hardest, right? And Lightning does a lot of complex things. So like, yes, it is doing a lot of stuff under the hood, and because of that, like sometimes the code may not be clean, right? But it is very well thought out and structured. So I would say like, don't be afraid. Like make a small change. We have tests. I think this is what you need to understand. We have a lot of tests, and we have every single PR will test everything, right? So you can make a change and fix something and know if it's going to break anything else because we have a lot of tests. So you don't have to be afraid of that, right? Like I think people, if I think about it, when I was kind of coming into CS, like making, like when I started to learn, like I think like even my first iPhone app, what I did was I found a GitHub app and I pulled it, and then I changed like a color, and I was like, ooh, it's no longer blue, it's not red. I was like, great, right? And I was like, oh, I can type in this text field. I was like, oh my God, that's incredible, right? And like if you just pull it and like tweak it and like change some of it, you'll understand it a lot better, right? So don't be afraid to come and just contribute. Do whatever you want. Like we will help you. Like it's not like you're doing this on your own. You're not gonna break anything. Like you're definitely not gonna break anything because we will catch it. The test will catch it. Something's gonna happen. And like I will like it's also a learning opportunity. Like you get up there, you try to make a change, and we will get up there and say, hey, this change will break this or that. Think about this, try to structure it this other way. Like it's a learning opportunity. Like where else do you get to learn from people who've been doing this for a long time and like know this stuff really well, right? Like this is like a mini PhD for free. Like all you have to do is just contribute, right?
Exactly. Uh, do you think there are any core design philosophies in place for the API or the community that have come together over? I think it's just under 2 years right now.
Yeah, I mean, I think we've standardized a lot of things, right? So Lightning introduced the Lightning module, right? I think like that is the first time that anyone's ever grouped all the things you need for a model together, right? Like even if you look at Keras and these other frameworks, like they all have optimizers and things dangling outside of it, right? But like all that stuff in Lightning is encapsulated. So I think there's an API of like training step and validation step and these kind of things. And these things did not exist before, right? Like we introduced those and put them together. Now what existed before Lightning were like trainers, right? People had trainers and like they had their own ways of doing stuff. And so I think like we've adopted a lot of what we do in Lightning from our own work and research as well. And I think like what people are kind of standardizing on is something like a Lightning structure, right? Where you can kind of train models and so on. Like that's actually really cool because it means that all the models across the world would be able to work together, right? And like I think that that's a really cool idea. Like something that used to frustrate me a lot. I mean, I have a lot of frustrations about machine learning because I'm someone like I don't I don't want to sit idle and just like let these things happen. And I think when I started doing research back in the day, like 2015, um, I remember having to implement baselines, and I was so annoyed that I couldn't just find something that I could just run and it would work, right? And that wasn't standardized. And I was like, why isn't all this stuff just standardized so that you don't have to do this? Like, how many data scientists, machine learning engineers, PhD students spend like 9 months implementing baselines, right? And then they run their own stuff. That sucks. Like that's super slow. So I think with Lightning, if everyone standardizes on the Lightning module structure, that means that we should be able to kind of go around the world and like pull any GitHub repo and play with each other, right? And like run the baselines. And so that's a really cool idea. And I hope that we continue to do that, right? And yeah, I think like, we continue doing a lot of work on here, but it's turned out to be very resilient, right? So the Lightning modules decoupled the data from the model from the hardware, right? So the Lightning module is just the model, which is really cool. And yeah, it just makes reusability much easier.
All of these things people tend to ignore. We were just talking about. I have this rig in the background just because it's a good conversation starter, and I suck at starting conversations. We were just talking about how different GPUs can also bottleneck stuff, and these are things that people don't realize, but you have to worry about it. Either you could worry about it as a user, or it could be taken care of. So I think that's where all of this comes into play.
Yeah, exactly. I mean, like honestly, like it's just like a different time in the development of AI. Like um, people are used to kind of learning from scratch everything. Like what's a for loop, what's a backward pass, forward lap, calculus, statistics, all this stuff. But like we're at the point where like you don't need to know that. Like, you could just learn Lightning directly and like don't worry about it. Like you can dig into it later. It's like no one like imagine if every time you wanted to drive like buy a car, you would have to sit through a class on physics and like combustion engines and like mechanics and fluid mechanics and like all these different things, right? Like that, no one does that. You just buy the car and you just drive it. And then certain people really enjoy cars and then they become mechanics and they really know how to work the cars, right? So just do the same. Just forget about all this stuff. Just start with Lightning, run it. And then if you really care about how it works, you can look into it and make your own modifications. Do your own distributed training. It doesn't matter, right? Like we're super flexible. You can do whatever you want in Lightning. But I think it's just a time for a different paradigm shift.
That allows me to segue into the masterclass that you've been putting together, and even content otherwise. I really loved your, actually had read your articles on Forbes and then realized they are by you while doing my homework, so thanks for those. What makes great AI content? There's this tendency to also overhype stuff, overmarket stuff. What according to you is great content?
I think great content is educational and factual, right? And I think that when we're going into machine learning and deep learning, we're entering an academic world, right? Like it is largely academic right now, and academic is ruled by ethics, right, and attribution, right? Because we build on each other's work. I think the beauty of academia and machine learning and AI is that people are allowed to come up with things, and then people build on top of those things, right, to build even better things, right? And so I think great content is one that highlights that how to work with things together, how to build on something, how to take an idea and make it and take it farther. But I think you walk away with knowing something new that you didn't know before, right? I think that that's content. But I think at the heart of it has to be being ethical and being factual about what you do, right? And I think that probably the more hype that you hear about a startup or some sort of machine learning idea, probably the less likely it is to work. Like in fact, my last paper, we published a paper on contrastive learning, and a lot of the paper is about that. It's about dehyping a lot of this because you see these methods, BYO, SimClear, all these things come out, and at the end of the day, they're all doing the same thing. Like it's all the same stuff with just one minor tweak, right? And a lot of this, when you read the papers, it's really hard to know as a as not a researcher that like people rationalize later. Like they find something and then they're like, oh, okay, I think it's because of this, and then they come up with some crazy math to like prove it, right? And it's like, well, that's just not true, right? Like, and so I think contrastive learning today is suffering from a lot of hype as well.
What does a process for you look like? I've enjoyed your articles on Forbes. I've enjoyed your articles on Medium. Both cater to somewhat different audience. What's a process for you like when you're creating content? Even with video, when you're creating a lecture, for example.
I mean, I think I just find stuff that I'm interested in, and things that because I'm reading all the issues and Slack, like I know what people want to know about as well, and what the major topics of um, discussion are, and like I just want to extrapolate and explain to people. Like I think I aim to give people insight into something that they may not know about, right? And I think I have the benefit of working with amazing people, like who are just brilliant, and I can learn a lot from. And so I try to relay a lot of what we talk about through these articles as well, right? Like so you're not just getting like me writing about something, you're also getting like the experience of Facebook AI, of Kyunghyun, of Yan, of Silver, of NYU Slab, right? Of the Lightning community, of a lot of people through there. So you're hearing a lot of explanations as well, where I'm trying to just bring it down to a more natural level so people can understand it. So yeah, I think I tend to focus and try to make things accessible. I think probably I have the hindsight of like literally not knowing how to code. I mean, I only learned how to code in 2013, right? That's not that long. So I can relate to like what it's like to look at a wall of, I don't know, cryptic text and be like, I don't know what this is, right?
And your journey as we're going through this interview, I actually was trying to connect the dots in my head. I went through all of your articles. I could see the iOS ones from earlier. Then you're talking about how to train something on 128 GPUs, which we just talked about. It's really fascinating for the audience. I'll have William's blog linked in the show notes. Would highly encourage everyone to check it out. I've really enjoyed it.
Yeah, I'm glad yeah, you're finding it. I mean, I guess a question for you, like what kind of content do you enjoy reading? Like what excites you?
Depends on different forms that I'm trying to consume. So if it's a blog, I would really like some depth to it. If it's a video, I would like some engagement. And if it's a podcast, I hope it's nicely produced. So that's very broad just because I'm in this world. But otherwise, I would, if I'm giving someone my time, I would like to learn something that they promise. So just like you said, I hope it's factual and not a waste of my time or not repetitive.
Yeah, no, that makes sense. I think I also find it frustrating that, if you Google something, so I wrote something about VAEs a few weeks ago, and I mean that's something I've been meaning to write for many months, because like Google VAEs for color, like color images, good luck. Like there's nothing, and also there's like so much wrong stuff, right, everywhere. So I think we're also suffering from like a curation problem in machine learning at the moment.
There's this also way of clickbaiting, but not quite, where you talk about some stuff and you talk about it, but you don't teach the person how to create it. You just teach them a very vanilla version of it, and it leaves you mildly angry, but you can't be angry because they're not wrong, they're not right either.
Yeah, but it's actually doing a disservice, I think, because it will teach you like some ideas don't they're not like, math. We have this idea of um like you extrapolate, right? You go from one and two and then the end case, right? So proof by induction. And I think articles assume that they can do that. They can teach you an MNIST and then somehow that'll translate to ImageNet. Like, no, it doesn't. Right?
Yes.
So I try to come up with realistic stuff that like would be able to translate to the more scalable things, right? Because like no one needs another VAE article on training MNIST, because it's really not representative of like what actually happens when you actually want to use VAEs in the real world.
Exactly. So we sort of took a segue coming back to the journey of Lightning. At what point did you decide to put together a team? I think you even co-founded Grid.ai, which is the company that is spending money on Lightning, if I'm correct. So how did you make that decision? Was there any hesitation because raising money for an open source project, there can be diversification in the goals? Were there any such hesitations?
Yeah, I mean, I think I think first and foremost, I care about the community and kind of like keeping things open and accessible to people. So I was very hesitant for a long time to do anything like that. But I think I realized that we also needed it, because it is extremely hard to maintain a fast-growing open source project. I'm dedicating 24 hours a day every single day for a year, right? And so you're gonna get burnt out at some point. And so I think like a lot of that money was like, okay, let's hire people to do this stuff full time. Like, but the problem is Lightning is super advanced and we do a lot of crazy stuff. So you need really amazing people. And so you have to, pay them well. And so that's a lot of why like we would go for like a venture fund, right? Because like they can provide these kind of resources. And then Grid, obviously Grid is supporting Lightning and providing all the funding and resources behind it. Because I think as companies continue to adopt Lightning, like they need to have reassurance that it's not just randomly going to disappear, that when they have a bug and it's critical, we're going to fix it, right? And I think that's the difference between something that's a kind of side project and an actual product, right? And I think Lightning is now a product, and it's something that if you do need something, like we will get back to you immediately and help you, right? Like your company is not going to fail because of it. Your research project's not going to fail. And so those were some of the hesitations, right? And then I think Grid is about helping those companies scale up, right? So companies have very different requirements, and at the end of the day, like there's a lot of stuff that if you want to scale it up with Lightning, you have to do it manually. You can still do it, and there are plenty of tools for this. But Grid just automates that, right? Why? Because like companies just want out of the box solutions, and that's really what we're trying to provide.
So could you tell us a bit about Grid and your role? It seems like you're focusing more on making machine learning infra independent. I just have 3 GPUs now, but I used to have 1 GPU. Why do I need to worry about this stuff? At what point should I worry about this stuff?
Yeah, I mean, I think anytime you're trying to, I mean, I have a few GPUs at my house, and that's great for debugging. But as soon as you try to train anything that's meaningful, you might have to scale up somewhere else, right? You might have to go to AWS or some cloud or your own cluster or whatever. And so that's what Grid helps you do, right? So you can train at scale. So you can come to Grid and spin up 100 machines like that, no problem. You don't have to do anything. And so it's really meant for people who need that scaling, right? Who needs the scaling? Data scientists, machine learning engineers, a lot of company people, but also researchers, right? Like if you're doing serious research, you're going to have to scale up a lot. And even for hobbyists, though, like you can come and if you want to do Kaggle competitions or whatever you want, you can spin up 50 machines very quickly in Grid and be done with it in 20 minutes, right? Whereas it's about trading time and speed, basically. So that's a lot of what Grid helps you do.
So if I'm taking part on a Kaggle competition and if I have GCP credits in one and AWS in another one, I don't have to worry about learning the API. Also, I can just use the CLI, I assume, for that task.
Yeah, exactly. So you can just come in, drop your project, train some stuff, and then be done with it, right? So I think like we have an early access program right now where you can obviously sign up and get early access to that, and then you can try it out. So we're still not fully public, so we there are a lot of cool features that I'll have to tease you with.
Sure.
But yeah, I mean, if you want to do Kaggle competition, I think Grid is an amazing resource, obviously. So yeah, you definitely try it out. But feel free to sign up. And we have a long list right now, but we're trying to get through people quickly. And we'll ping you and onboard you, and hopefully you can try running some things and see how it goes.
I'll have the website linked in the show notes as well. Uh, Generally speaking, I'm very curious about how you balance time. Does it go back to your roots from the army, just being very stringent with about how you manage your time, or is it completely passion driven? Because you're also doing research, you're also leading teams, you're also maintaining the open source code. Your GitHub has the almost perfect year where you have a commit almost every single year. I was just looking at that. So how do you manage your time?
Yeah, I think a lot of it comes from the military. I think when you're going, I think especially for special operations, like you're like, and again, like I did not become a Navy SEAL, so like I think you obviously learn a lot more once you're doing a lot of deployments in the SEAL teams for a lot of years. But at least what you can take away from training is like an intense focus on something, right? Like nothing else in the world exists except that one thing, right? And like that's the kind of mentality you need to be able to get through stuff. So I tend to, when I code and I work, I tend to just focus only on that thing. I'm like, I don't check phones, I don't check email, I don't get distracted. I like kind of, I don't know, just like overly focus and completely dive into that, right? And so I think people call that flow. I don't know, like I just what I was trained to do. And so I tend to just jump into that mode very quickly and stay there for a long time, and I won't come out of it until I'm done solving that problem, right? And that's why I also try not to code in the afternoons, because if I recommend this for everyone. Like, if you're coding on something hard, don't start in the afternoon, because it may take you until 3 in the morning, right?
We've all been there where we started in the afternoon and you look outside, the sun is coming up and you're thinking,
Yeah,
is it dusk? Is it dawn?
and it's always like this. It's like, okay, oh, I found it. It's like, right, I just need to run it. It's gonna fix it. And then you're like, oh, that's not it. And then like it's always like you're almost done for 7 hours, right?
uh, do you have any other learnings that you could share, probably from leading teams at two startups, just generally speaking, or any insights that you've learned from leading teams of people?
Yeah, I mean, I think like I was taught to lead from the front, right? Like I think in the SEAL teams, like you're never gonna do something that like I think it's one of the unique places in the military where everyone goes through the exact same training, no matter what your rank is. So you're sweeping the floors with everyone. Like doesn't matter what your rank is, you're freezing, you're going through all the hard stuff together. But as a leader, you're always doing it first, right? And so I think I always lead from the front. Like I will never ask someone to do something that I haven't done or can do or will do with them, right? And so I think leading teams is about. I think you can get it really far by just being there, like being the person that's like inspiring and like going really hard, and like think about it as a race. Like if we're running and the team is running with you, like I'm gonna try to be running really fast so everyone else can keep up, right? Whereas I think you have other approaches which are more management, and that's less effective, right? And that's managing is not leadership, right? Managing is, did you all run the race? Great, good job. Practice and do it again tomorrow. Whereas a leader, it's like, hey, I'm running with you. Okay, now you're tired. Great, let's go run again because I'm gonna do it. And if I can do it, you can do it, right?
That's a difference between leading and managing, for sure. Um, Zooming out, you're also interested in AI for social impact. Do you have any favorite projects that might have come up in the recent times, or anything that you are excited about in this domain?
Yeah, I mean, I think there's a lot of stuff on privacy right now. Federated learning, I think, is really interesting. But I think also like um, there have been a lot of like boot camps in places like Indaba and Latin America to teach people from other countries, and I think that's really powerful, right? Because we have a really big problem today in AI of underrepresentation, right? Where everyone's like the same background, and um, I think when you're coming from places like Latin America, like it's really hard to get access to these resources. And I'm fortunate enough to be in the U.S. and like I moved when I was around high school, and so like I've had the luxury of being able to, and the privilege now of like being here and being in this system and like knowing it now, right? But a lot of people don't, right? And so I think it's really important for those of us who like are here and have access to these resources now, and like know where we're coming from as well, to give back and to empower those communities as well, right? So I care a lot about that. I care a lot about diversity. I care a lot about who's getting into machine learning and AI, because after spending time in the military, going through public schools, and then going to like an Ivy League school, I realized that like the difference is a lot of times is not really intellect, it's opportunity, right? It's like there are a lot of really smart people who, given the same tutoring and everything else, would be in the same situations. Um, so I think it's just about leveling that playing field. So I think on the research side, I'm not. I think a lot of the work that people like Tim Knit are doing for debiasing and highlighting these issues is really powerful, right? And I think that we need to continue doing that. And then I think beyond that is also the kind of like reach of teaching people, right? And so I think Indaba was a good one. There's one in Latin America as well. So if we can continue to build these like that, that's I think what we'll take to kind of like bring people into the field. And honestly, like we want to make impact in these countries, but like unless you're from there, it's very hard to do, right? Like there's this weird thing in Silicon Valley. People are like, "Oh, I'm gonna change the world," in like low income Mexico. And you're like, you never even been there. You're not from there. Like that's crazy, right?
Exactly. I had a chance to interview Sarah Hooker from Google Brain, and we were exactly talking about this. In India, I stay in a small city. I have three backups of internet. One is my phone, another dongle right here, just because I can't rely on the fiber internet at my home. And people in the US don't understand what this is, just because they're so
Yeah,
used
they
to it.
take it for granted. It's crazy. Like they take things for granted, like even electricity, like Venezuela, right? I mean, blackouts all the time. Like imagine, you know what I mean? Like you have to worry about your electricity. Like what, like the privilege is so embedded that you know, in the US, you can sit here and like, you know, you're going to eat, you know, you're going to have electricity, you know, your computer is going to work. You know, you have an access to a cluster probably. And like, even those basic things, like it's so embedded that you have no idea. Other people, they're like, man, am I going to make it to a library today? I'm like, is the power going to go out? Can I train models? Right? Like, I don't know.
I paid as much as my 2080 Ti for a UPS just because I need power backup to sustain model training.
Yeah. So I think we all need to be aware of that. And like, I don't know, just give back. Like, you know, do what you can to give back, because inclusion and impact is going to come from people in those communities going back and doing something for the communities, right? So yeah.
We definitely need more leaders like you. Another broad question, and you can pick one or two or maybe more projects. Any favorite things that have come out of PyTorch Lightning community? Any projects, any research work, any competitions? I know there are many Kagglers who use it extensively now.
Yeah. Yeah, actually I love I think Dieter's doing a great job on Kaggle. He's like winning things left and right, which is amazing. I think TorchDin is really cool as well. So this is PD. So I don't do PDs, right? I don't. So to me, it's just amazing. Like the stuff that you can do with it is really cool. And then I think NVIDIA Nemo is amazing. Like Nemo is bringing in a lot of like text to speech, automatic speech recognition, NLP, in like such a simple way, right? And like making it super accessible. So it's a really cool projects, and I think people should definitely check them out. I mean, people build things with Lightning all the time, and I try to stay on top of it. There are a lot of cool things. Like just get on the. There are over 1,000 projects that are open source right now, right? I mean, you're not even talking about like the things that people and companies are doing, right? Like we have yeah, I won't say it now because we'll have some articles and stuff come out, but like really incredible science places that like, you know, people like they're doing an incredible job working with Lightning. And the stuff they're doing is phenomenal, right? And so, yeah, like, I don't know, it's, I'm very humbled, obviously. And like, you know, I think we take a lot of the credit, but like a lot of it honestly goes to PyTorch and, you know, the team there, like they're doing incredible work. We're simply just making it more accessible. And like, we work very closely with them now and a lot of features and new things. Like recently we released Sharded, where, you know, you don't have to do anything to Lightning. Literally change a string, just plugins equals Sharded, and then you can get memory savings on your models, like 50, 60%, right? Like everyone can try this today. Like you're just running Lightning, go plugins equals Sharded, and it'll work. And that stuff comes from Facebook that we worked on with them, right? And like they implemented this and they spent a lot of time working on this, and we helped them integrate it. And like through that process, we both learned a lot, right? And so these collaborations will continue, and I think it's very beneficial for everyone. So again, yeah, like Lightning, I think is a place where you're going to get access to a lot of these like new things that are coming from these crazy companies. But just check out the projects; they're really incredible. Yeah, I wish I had more examples right now. I think those are the ones that stand out at the moment because I was also looking at them recently. But Facebook has one too. It's called Faster Mirai. That one's really cool. So check that one out.
Okay. I'll try to have all of these links in the show notes. My final question, it's usually a repeat one. Generally speaking, what's your best advice to someone who's just starting their machine learning journey today?
Yeah, I think forget about. I mean, I think everyone's gonna hate me for this, but like, don't worry about calculus. Don't worry about statistics. Like, it's fine, right? Like, it's not a huge deal. Like, go start with a high level library. Like, it doesn't matter what you use. Just start with a high level library. Obviously, I prefer to use Lightning and try it out, but there are a lot of great libraries you can start with. And then just solve tasks. Just solve something, right? Like solve classification. Solve um, you know, anything. Kaggle is probably a good place to get started just to try things out, right? But just try to get to a point where you can solve something first and then dig in if you care about it, right? Like then dig in into the calculus, then dig in into the stats. I think if you're going to go into a professional setting where you do want to use machine learning, you will have to know a little bit about it. so that you can make some tweaks and obviously know what a distribution is. But like, don't let the math be the bottleneck as to why you're not getting into machine learning and deep learning. Just take it for granted. Like, you're not like, it's to me, it's like, again, the car. It's like you choosing not to drive cars because you don't know how an engine works, right? Like, I don't know.
uh, Top-down learning, I'm a huge fan of it. I come from the fast AI world, which is very similar to PyTorch Lightning, and I'm a big believer of it.
Yeah, and honestly, like, I think they've done a phenomenal job at doing the top-down learning, right? Like, and I think that's what a lot of libraries for, is to teach you those things, right? And so I think it's a good example of executing that well.
William, thanks again for your time. Your _Will Falcon on Twitter. That's his username. Also there in the show notes. Any other places where people from the audience can connect with you?
Yeah, Twitter and, GitHub. So open an issue, submit a pull request. I'll probably answer you at some point. Slack, we have a Slack community as well. But really, like, we help you with anything. Like, people come up there asking about everything, and we help them. They're like, oh, I can't implement this, or I can't run this, or whatever. We will work with you, right?
Probably don't open an issue saying this was a good episode. Please send him a tweet. William, thanks again for your time and for sharing such an amazing journey that you had and for such an insightful conversation.
Well, thank you for having me, Sanyam, and amazing. I'm a fan, so yeah, I hope people continue listening to the other episodes, and continue learning from you. So thank you for what you're doing as well.
You too, kind. Thanks.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.